Hello, I'm Ethan Cooksley, and this is my PowerPoint presentation on network principles and protocols. So first, we're going to be looking at network types and physical connections. So first, that wired is stuff like cables and network interface cards. So it tends to only support Ethernet, and which is the cable which goes from the router straight into your PC to give you a stronger connection. And then some benefits of it are it has a dedicated bandwidth, it has long-term deployment, it has stability, faster speeds, and increased security. Although there are also a few constraints, such as it's quite costly to deploy, it's a bit inflexible at times, it lacks mobility where it all has to be plugged in and it physically connected. The maintenance, and then it has higher infrastructure needs as well as it will need cable management. Otherwise, the cables will get all tangled, and that can even cause some issues in some cases. The next network type we have is wireless, which uses different aspects of the radio spectrum to communicate. It it will use different parts depending on the function that it is doing. So networks in the UK also have 2.4 gigahertz, 5.5 gigahertz, and the new 6 gigahertz frequencies, and this is for both broadband or corporate use. The only so it's only the only cable that's required is from the router to the access point, and then we've got some benefits, which are it's quick to deploy, it's flexible, it supports mobility, it saves costs, its extensibility, and it has customer opportunities. Although there are some constraints, which are it's got a shared medium, it has a lot of security concerns, its coverage, interference, and then you also need trained personnel as well as it has less bandwidth. And then you've got hybrid, which is a mix of both networks, and it depends on how the network would be set up. So it could either take some aspects of wired and some aspects from wireless, and then it can also do vice versa, just taking bits and pieces from each one. Next, we have our network standards. So first off, there's the OSI. OSI is used worldwide for communications that assist in the implementation of the network protocols and its 7 layers. So OSI's 7 layers overall. They have 3 upper layers and 4 lower layers. So the upper layers consist of the 7th layer, the application layer, the 6th layer, the presentation layer, and the 5th layer, the session layer. Then its lower layers consist of the 4th layer, the transport layer, the 3rd layer, the network layer, and then the 2nd layer, data link, and finally the 1st layer, which is the physical layer. Next, there's TCP/IP, which is the most common network protocol. It's also known as the Transmission Control Protocol / Internet Protocol. It's a standard that governs the sending and receiving of data, either on the same network or across different networks. While OSI has 7 layers, TCP/IP has less layers, only having 4, but the TCP layer has combined the layers from OSI to its own. So, such as the 4th layer, which is application, is equal to OSI's 5th, 6th, and 7th layer. The 3rd layer, the transport layer, is equal to the 4th layer of OSI, and the second layer is the internet layer. It is equal to OSI's 3rd layer, and finally we've got the 1st layer, which is the network access layer, and it is equal to OSI's 1st and 2nd layer. Next, I'm going to be covering network topologies. So there's a few different types of topologies. Some different types are a star topology, a mesh topology, a tree, and then a VLAN. So According to Prasanna 2022, star topology i- is it's when all gadgets are associated with a focal switch, which makes it simple to add new hubs without rebooting all of the now associated gadgets. This topology utilizes links and is not difficult to oversee. But then again, the strength of the switch is imperative. This topology requires observation and support. Notwithstanding, it is a usually experienced topology. So it has a few advantages, which is adding on removing any hubs is quite simple as it does not affect the whole network. Uh, Information bundles don't need to hop between different hubs. They can just go, but they don't need to hop between numerous hubs. It is easy to recognize any flaws with the network gadgets as they're all separate and it's not all one link system. So you could see which specific one is causing the issue, as it won't be working compared to even though all the other ones will be. Although it's got a few disadvantages, which are due to all the activity being centered on the focal point. If the focal point breaks, then the whole network will also break. Then the quality of the hubs depend heavily on the focal point as well, and finally, it also has quite a high cost. So this is a star topology. I've put a diagram on the slide, as you can see, of what it looked like. So it's just got its main hub with its it'd be 4 pieces of hardware coming out with it. Then this is a tree topology. As we can see, it's as well as the start, it has its main focal point, and then it has its other devices branching off, and then yet again a tree topology, it branches off again. So next up is communication requirements. These refers to the specific needs of an organization or network in terms of their data exchange, collaboration, and interaction. These requirements can vary based on the nature of the business, user demands, and the types of applications and services running on the network. So, uh, for, so for our communication principles, three things need to have. So these three things need to have a conversation. Uh, to have a conversation, these three things need to happen or need to be there: a source or a sender, a destination or receiver, a transmission medium such as a cable, wireless, sound waves, and light. So some advantages are efficient collaboration. Proper communication requirements facilitate seamless collaboration among employees, departments, and remote locations. It enables real-time communication, file sharing, video conferencing, and other collaborative activities, enhancing productivity and decision making. Enhanced data sharing. So this is another benefit. Effective communication requirements ensure smooth and rapid sharing of data, information and resources within rapid sharing of data, information, and resources within the network. This promotes efficient workflow, reduces duplication, and facilitates knowledge sharing. Uh, then our final advantage is streamlined workflows. By understanding the communication requirements, network designs can be tailored to optimize workflows, streamline processes, and improve overall efficiency. Some disadvantages are increased bandwidth demands. So communication requirements, especially for data intensive applications like video conferencing or multimedia streaming, can significantly increase the demand for network bandwidth. This may require network upgrades and increased infrastructure costs to support the required communication capabilities. And then next and finally, for our disadvantages, we have network congestion. So inadequate communication requirements planning can lead to network congestion, resulting in poor performance, latency, and potential data bottlenecks. This can adversely impact user experience and productivity. Next, we have bandwidth. So bandwidth requires to the capacity of a network to transmit data within a specific time frame. Bandwidth requirements determine the amount of data that can be transmitted simultaneously and the speed at which it can be transferred. Its advantages are its fast data transfer. Sufficient bandwidth ensures quick and efficient data transfer, enabling high-speed communication, file sharing, and application responsiveness. It reduces delays and enhances user experience. Next, there's scalability. So identifying bandwidth requirements allows for network scalability to accommodate future growth, increased user demands, and emerging technologies. It ensures the network can handle expanding data traffic without performance degradation. Then finally, there for our advantage, there is the multimedia support. So adequate bandwidth is essential for supporting multimedia applications such as video streaming, VoIP, or also known as Voice over Internet Protocol, and video conferencing. It allows for smooth and uninterrupted media transmission. Next, I'll be covering the disadvantages of bandwidth. So our first one is cost considerations. Higher bandwidth requirements often translate into increased costs for network infrastructure, equipment, and service subscriptions. Upgrading bandwidth capacity may require additional investments. Network congestion in scenarios where bandwidth requirements exceed available capacity, network congestion can occur, resulting in reduced performance, packet loss, and latency. This can also impact the user experience and the overall network efficiency. And then next we have over provisioning. So overestimating bandwidth requirements can lead to unnecessary costs and underutilization of network resources. It's essential to strike a balance between meeting current needs and planning for future growth. So next I'm looking at topologies communication. So I'm looking at the previously three mentions impact on network design. So in network design, understanding and properly addressing all these requirements are critical to ensuring an efficient and reliable network. By carefully assessing the requirements, network architects can design scalable and cost-effective solutions that meet the organization's communication needs while optimizing bandwidth utilization and mitigating potential disadvantages. Next, we have our networking devices and server types. So there is for our network devices, there is routers, which are used in LANs to move packets from a network to another. Then there are switches that allows for communication between the devices. Firewalls, these stop illegal access to the network. It can come in both a hardware and a software form. Then finally, for our devices, there is repeaters. It's a device that helps in boosting signal strength by forwarding the signals from a router so that it covers a wider area. Next, I'm going to be covering our server types. So our first server type is DHCP, which is a dynamic host configuration protocol. A DHCP server is responsible for assigning IP addresses and other network configuration parameters dynamically on two devices on a network. It allows devices to join a network and automatically obtain the necessary network settings without manual configuration. Our next server is a web server. So a web server is designed to host websites and deliver web content to clients over the internet or a local network. So it responds to requests from web browsers and serves HTML pages, images, files, and other resources. Communication web server software includes Apache HTTP server, and Nginx and Microsoft Server Information Services, or IIS. Our next server is DNS, also known as Domain Name System. So DNS servers are responsible for translating domain names, such as like www.example.com, into corresponding IP addresses that computers can understand. When you type a domain name in your browser, the DNS server translates it into the associated IP addresses so that the appropriate web server can be located. FTP servers, or file transfer protocol servers, enable file transfers between computers over a network. So it allows users to upload, download, and manage files on a remote server using the file transfer protocol. FPT servers also provide a way to share files and collaborate across different devices. Next, I'm going to be looking at common networking principles and protocols. So our first one is IPv4. This is the most widely used network protocol for communication on the internet. It's widely supported by network devices and operating systems, and it ensures backwards compatibility with legacy systems. However, the limited address space and need for NAT have led to the adoption of IPv6 addresses. These addresses allow for efficient routing and organization of networks. Then there's IPv6, which is the successor to IPv4 and was designed to address the limitations of IPv4. It allows for the seamless connectivity of a vast number of devices, including the Internet of Things, IoT devices, providing native encryption, authentication, and integrity checks for network traffic. It enhances the security and privacy of network communications. And then finally, we've got HTTPS, which is an extension of the HTTP protocol. It adds encryption security features, ensuring secure communication over the network. Many regulations and security standards use digital certificates to authenticate the identity of web servers. This verifies that the user is connecting to the intended website and not an imposter. So it would be mitigating the risk of phishing attacks and impersonation. It can also encrypt data transmitted between a web browser and a web server. This prevents the unauthorized interception and eavesdropping, ensuring confidentiality. IPv4 and IPv6 are fundamental network protocols that enable communication and connectivity in the digital world. So IPv6 addresses the limitations of IPv4, such as address exhaustion, and it enhances the scalability, security, and efficiency. HTTPS, on the other hand, ensures secure and encrypted communication over the network, safeguarding data integrity, authentication, and confidentiality. So together, these protocols play vital roles in enabling effective network systems by providing robust networking infrastructure and secure communication channels. But then we also have, so finally, we have our hardware and software dependencies. So workstations. Workstation is a computer which is used by a singular user or a group of users to accomplish their goals and tasks. In this scenario, the workstations will be the host desks that the employees can be connected, the employees can connect their laptops to, or it could be also be one of the meeting rooms that are being used. Next, we have our servers. So servers are a hardware or a software that provide management for network resources. There are different types of servers, as previously mentioned on the previous slide, such as the HTTP web server, DNS, and FTP. Next, we have the interconnection. We have interconnection devices. So interconnection devices are devices that allow for the transfer of data on networks. There are some different devices that can do this, such as routers, NIC network interface cards, or a network bridge and switches. Next, we have our network software. Our network software observes and manages networks. An example which I've previously mentioned is software servers. Other examples include firewalls, operating systems, and client software. The hardware and software relation is a strong. The relation between hardware and software is a strong one. They rely upon each other heavily, and one cannot function without the other. The hardware needs softwares to run, but then without the hardware, how could the software receive its instructions to run the tasks? multiple softwares can be installed on the hardware at once to perform a number of different tasks. So software is what allows the communication between the user and the hardware that performs the number of tasks. These are the references that I included in my presentation. Thank you for listening.